Okay, so as I was mentioning that let's say this function one has this parameter a. Okay, so this parameter should be accessible from this main. Why? Because in order to convert this into three address code, in three address code we have a call, the function, and after that we have what? How many parameters are there? In order to have this information after this, like inside this three address code, we obviously require these parameters to be declared, the parameter regions to be declared. So this, so at the very bottom is basically the actual parameters which will be required by the called function, the function which we are calling. So this will be required by the caller. This is the caller and this is the callee. So caller is basically calling this function. Hence, this caller requires this parameter informations to be stored, which is stored in this actual parameter or the very bottom of the bottom of the, let's say, the activation record. So this is how a record actually looks like. Yeah. So this is basically how the record of a procedure or function or activation actually look like. Now, let's see a state of how things work. Let's see one of the stack state. So in this scenario, let's say while we are in this M, the first scenario is basically, let's say, we have in the source code where we're declaring this A, isn't it? A is the array at the very top, even before calling this main function. Hence, we will be storing this integer at first, integer A at the very beginning. This has been stored at first. After that, we have this record for this main part. So this is the mains record. The record for this main, this is the mains record. Now, from there, we are calling whom? We are calling R. So once we are calling R, let's see the function of this R. Inside this R, what do we have? Inside this R, we have the record for this, the read array. So record for read array. And inside this R, we are also have what? Some local variables. So the local variable in this case is, let's say, integer I. So now this is what? The activation, the topmost element or the topmost part is basically what? The active R or activation of R. Before that, M was active, the main was active. Now, once R has like exited, we exit from the R, what happens is basically this will be get converted into this manner. This will be the, like this will be the scenario. So once we return back from R to this main. So now the record will be the topmost element or the activation or the active part will be the main up until we make a call to this queue. So once we now call this queue, what will be basically stored here is, now remember, before calling this queue, we have what? Inside this queue, we have M and N, who are the parameters. So even before calling this quicksort, we have what? This parameter M and N. So that means this parameter should be accessible from whom? From the caller. In this case, the caller is basically whom? The main. Main is calling this quicksort with this parameter 1 and 9. That means we need to store the information of those parameters. So this parameters is basically in this case integer mn. And after that, we have this record for q 1, 9. So this is the record for q 1, 9. Now, the topmost element of the stack is basically q 1, 9. And inside this q, we have what? The quicksort. Q is basically referring to quicksort. We have this I. So hence, there is this region where this I will be stored. I is being stored. Once I is being stored, which is in this, not in this scenario, from there, what do? We call this P. Now, before calling this partition, we again have declared what? We have to have this parameter stored. Now, parameter stored from where? Now, for the quicksort is the caller, and callee is basically whom? The partition is the callee, or the calling function. So we have this, wait, I'm again kicked out of the network. So just hold on a second. Yeah. So now we again declare integer amn, and after that we make a call to this p19. This is the record for p19. Once p19 gets exited or gets executed, again this gets popped. So this is popped. Now the also this m and n is no longer required, because this was only required for which part? For making call to this partition from this quick sort. Since we no longer require this m and n, we can also remove this m and n from this part. And again, now after partition has been called, we have what? We are calling the quicksort function. Hence, we will be calling the quicksort function. However, before calling this quicksort function, we have what? M, and with that we have comma I minus 1. So basically, again, this is also m and n. So we have this actual parameters as, let's say, integer m comma n, because we are now going to call this q function, quicksort function, with 1 comma 3. And from that one, like within, this is the record for quicksort 1 comma 3, and within this quicksort there's again what? There's again this I variable, which is the local variable. We again define this integer I. So now if you see one thing, these things are redundant, repetitive. However, none of these records are like synonymous or the same for everyone. Why? Because this is for quicksort 1 comma 9, and this is for quicksort 1 comma 3. So though their structure is sort of same, that mn is stored, then quicksort is called, and integer is stored. Again, after that, mn is stored, then quicksort is called, and integer I is stored. Since the pattern is same, however, the data inside are not same. That's why we require the data to be stored in this manner in the quicksort. So integer I. Now after this integer I, this quicksort, again this quicksort makes this partition a call. So there again, before the partition function is called, we again declare integer mn, and after that we go to the p's region, so 1 comma 3. Once p is exited, this integer mn also gets exited, and after that partition portion, we have again another quicksort function. So again we declare the parameters, which is integer m and n, because quicksort has the parameter m and n. And after that, this quicksort with value of value of 1 comma 0, 1 comma 0 is placed, and this is the record for quicksort 1 comma 0. There is no more execute, like there no more function call from this quicksort. Hence we pop this item. The topmost element is this one. From there we call the right quicksort function, which is this one, q3. Okay, so before that we also have to declare the m and n for the next quicksort, and then there is this quicksort of 3 comma 3, and this goes on. Okay, one gets popped, another gets like inside. Now if you see here, if this quicksort is existing, then before this gets completely popped, this quicksort, the parent quicksort function, the record for that has to leave. And before this gets popped or gets completely finished, this has to live inside the stack, because we are unable to extract this information from the stack until the top elements are extracted or popped, isn't it? So that's how it goes. Now, the very final portion which I wanted to talk is basically the calling sequence. Now, how the calling sequence like matters, or how this calling sequence actually works. This, like whatever we have seen so far, is basically the activation records of the quicksort and those sort of things, the activation trees and those sort of things. Now here, for the calling sequence, basically what will be required is how the calls are made.